So this is the 1-5 lesson, and in the textbook, on page 37, where this begins, the heading is one-to-one functions. And a one-to-one function passes the vertical line test and the horizontal line test. This is Algebra 2 material. And what that tells you is that this graph, this relation is a function, and its inverse is a function, without even graphing it. If it's one-to-one, it passes the vertical line test and the horizontal line test. Inverses. Two functions are inverses, if and only if f following g and g following f both take you back to the input. So we're going to do example 2, and you're going to see what that's about. For inverse functions, okay? So, for example 2, I'm on page 39. It says find the inverse function. So what they give you is negative 2x plus 4. So you see this graph right here, which is the pre-image. It's negative 2x plus 4. Where's that coming from? Well, it's y equals x. And it's been rotated because it's y, then it goes y to negative x. Y has been divided by negative 2. So the slope's negative 2 and the graph's been moved up 4. So you have this pre-image. And then you want it, this is a one-to-one function because this passes the vertical line test, passes the horizontal line test. So you want the inverse. It says find its inverse function. So to find the inverse, you take x and y and you exchange them. So for example 2, we would say the inverse is x equals negative 2y plus 4. And on page, the bottom of page 39, they distributed first. I don't think we need to, I really wouldn't do that. You just say x equals negative 2y plus 4, add a negative 4 to both sides, divide both sides by negative 2. It does not have to be in y-intercept form. Okay? So you're going to go to problem number 13. I'm going to leave that up there. And we're going to go through 13 and we're going to show you something on your calculator. So you can solve this problem without your calculator. We're just doing it, we're just showing you something after you've had time to do that problem. And 13 is just another linear equation. So you're all set. I didn't do the inverse for you on this one, but you can take it one more step for problem number 13. Okay. So there's really not too much. It's just a linear equation. We're going to give you a 1-minute warning on this. We're going to go over this, but it's a user-friendly problem. So it's kind of helpful to do to show you something on the calculator with a user-friendly problem and not waiting to get to a real challenging problem. So wrap up what you're doing on 13, and we'll go over this on the calculator. So, ready? Here's the pre-image. That's the question. X equals 2x plus 3. So the inverse, or y equals 2x plus 3. The inverse is x equals 2y plus 3. That's it. Then you take this thing and you solve it for y. So this work down here, we're going to do together on the calculator. So you're going to go to your calculator. You're going to go to y equals, and you're going to type the question y1. So the question for number 13 is 2x plus 3. So we're not going to put our answer in. So our answer is x equals 2y plus 3. So we're going to make it calculator friendly. So we would have open parentheses, x take away 3 divided by 2. That form is perfectly fine. The only issue with this form of leaving it like this is if it were multiple choice and you had to match it to, and it happened to be in y-intercept form. But if you're writing out an FRQ, there's no point in going past this. Okay? So now I push zoom 4 and take a look what you got. The pre-image is in blue. The image is in red. And what you did is you took the blue graph and reflected it over the line y equals x. Now, you don't need to do this, but I'll go down and put y equals x down here. And you can visually see how the blue graph gets reflected over the line y equals x and maps onto the red graph. But in terms of what we started with f following g and g following f, take you both back to x, that's here. So you go back to y equals. And I'm going to turn off y1 and y2. And I'm going to put this in here for y3. Now, you can put it down low. See, I've got some stuff in here. Y5 and Y6 are from chapter 2 and chapter 3. We didn't get there yet. So I've just got them out of the way. So you could put this, what I have in 3 and 4, lower if you want. So you can fit more stuff up here. But it's just meant to be there without you having to retype it. So I'll type the first line with you, and then you do the other one. So in order to type this, because this came up, somebody said, like, how do I find this? You know, you want me to type this in here, how do I find it? Okay. Vars go across the y vars. We're in function mode. We want y1. Open parentheses. Vars, y vars, function mode. We want y2. Because what does that mean? Well, parentheses on the calculator implies multiplication. But when you use the VARS menu, the calculator understands that you don't want multiplication, you want function composition. So when you type this like that, what the calculator is doing is saying, take y2, work inside out. Here's your y2. Make this the input in y1. So you would have 2 times this whole thing. Those 2's would reduce. You'd have -3 plus, you'd have x plus a -3 plus 3. The 3's would add to 0, and you would get an x. If you went the other way, y4, you have y2 following y1. So this becomes the input. When this is the input for this x, you double everything. So the 2's reduce, and you had x take away 3 plus 3, you'd be back to x. So now when I have 3 and 4 on, I go to table set. It doesn't really matter where you are. I'm at 0, 1. Second graph. You notice that y3 and y4 are both generating the input. That goes back to this. It goes back to, ready? y1 following y2 equals y2 following y1, and they both equal x. I lost my calculator. And they both equal x, all right? Now, if you were made a mistake and you go to y equals, and this was wrong, ready? Suppose this was that. Second graph, they're not inverse functions anymore. Sorry. They're not inverse functions anymore. So y3 and y4 are not generating the input of x. So it's a way to verify your answer with the technology, okay? So on here, there's my y3 and y4. And then y2, I wrote out in y-intercept form, which you don't have to. The calculator doesn't know. Are we good? Now, somebody had a question about this. Somebody emailed me a question about logarithms and like, when do you use ln, when do you use log, and when does it not matter? And we got a little ahead of ourselves in 1.3 by doing that work. The textbook basically wanted you to just solve those problems 2 sections ago by graphing. And I also did them analytically because I know you work with logarithms in pre-calc. But what you have to realize is this. If the base is 10, the base is 10, that's telling you to use log. If the base is e, it's telling you to use ln. And if the base is neither, ready? This is neither. We have y equals b caret x. This is an exponential function. The independent variable is an exponent. So the inverse function would be b to the y equals x. And the way we write that is we write it as y equals log base b of x. And you learn how to swirl this. You're just unswirling it. Swirling it is. The base is the subscript. B to the y equals x. So you're just undoing that. You go from b to the y equals x to log base b of x. These are inverse functions. They would be a reflection over the line y equals x, and they would meet that criteria for y3 and y4 both giving you the input. Okay. Now, one reason we did that, looking at properties of logarithms on page 41 at the bottom, here's 4 properties. I don't really care about change of base. We can work that out per problem. But the product property, you have to be familiar with these. This is why it works. It's up here if you're interested and you want to read it, but I'm not walking you through that. You can kind of see it. Log base b of this product can be broken down into the sum of the logarithms. And in the same way, log base b of x divided by y can be broken down into the difference of the logs. And then this is the property you would use most often, the power property. So if I have this thing, you can rewrite the exponent as a coefficient in front of the logarithm. And that's what we did in 1.3, even though we hadn't gotten to it in this book. And again, change of base, you can ignore this. This is true, but these will be applied during a problem. This you could actually work out during the question. You wouldn't really need to go in there with that ahead of time. Okay. So we're going to example 4. I'm on page 41. It says solve for x. So here's the first one. ln x equals 3t plus 5. You want to get x by itself. So I didn't do any work. I just rewrote this. ln x, it's the same thing as, you don't need this line in the second line, but if it helps you, good. That's why it's there to help you, but you don't need it. ln x means log base e of x. So from the second line to the third line, I just swirled it. E to the right side equals x. X is by itself. And you could go right from the first line to the third line. If you notice, hopefully you notice, this ln is telling you that the base is E. All right, and we showed you E yesterday in terms of the definition of E and how often you would use that in this course. So when you see ln, it's telling you the base is E. So example 4b is a little different. It's E, ready? This one gives you an ln. You have to exponentiate it. This one, you have to take a logarithm because it already has x is in the independent variables in the exponent. So you told us if it has an E, we should use ln, and it has a 10, we should use log. But this has an E and a 10 in it. Yeah, that's why it's a good question. But the point being, what we're trying to get to solve here has the exponent, E has been raised to the exponent, so we want to use ln. So we have this side right here. Take the ln of both sides. This thing right here, I didn't write it out. You got to compare this to that. So this question becomes, what is this thing equal to? And ln and E work against each other because they're inverse functions. But I don't want you thinking about it like that. I want you to think, okay, here's what this is saying. Log base E of E to the 2x. Log means exponent. What exponent do you raise E to? So you end up with E to the 2x. This is saying ln, loge. What exponent do you raise E to? E to the right side equals E to the 2x. So it's 2x. So 2x equals ln 10. Divide both sides by 2, and you've got x by itself. All right? So all you're doing in chapter 1 is a concentrated review of things you saw in Algebra 2 and pre-calc, except when you saw them in Algebra 2 and pre-calc, you took multiple days to do this stuff. And you also, had your spring semester interrupted. So I don't know how well people process this going back. We need you to be proficient with the algebra and trigonometry in order to succeed with the calculus. So I'm leaving this up here. That's your model, and you're going to problems 33 and 37. Now, the other thing is this document, this PDF, is in Canvas. So I'm sharing the screen, but you can open the document in another window. And then if you get stuck, it's perfectly fine for you to peek at the answer to get a prompt, not just copy it down. Peek at the answer. Okay, I see where he went from there. Let me move the page back up, and I'll pick up from there. So if you're spinning your wheels, open this document up, and if you need a prompt, take a look at it. Okay, you're getting the 2-minute warning. So the book sent you to 33 and 37, which is just like the example. It's one of each. So in 33, what happened? 33, ready? The question was an exponential. 1 and 45 thousandths raised to the t equals 2. Well, take the log of both sides. Could be ln. You could have done an log. You get the same answer. You're using the property. You can bring, I left out a line, so make sure you can see it. You can bring this t out front, and you divide both sides by this constant, ln 1 and 45 thousandths, and you're left with this, which is a number between 15 and 16. So it says confirm graphically, so I put the left side of y1, the right side of y2. That was the 2 before I applied the ln, the way it's written in the book. I went down here in my table to my answer, and y1 is generating a 2. Which is confirming the answer graphically. So it truncated here. I put it to 3 decimal places, and it truncated that because whatever this number is, after 4 decimal places, it goes to 2. Because this answer has been truncated. That's been truncated more. The exact answer is just like this. Okay. And in 37, they gave you ln, so you're going to exponentiate 37. E to the right side equals y. You're done. So tomorrow we will do 1-6, which is the trigonometry section, and then we're going to talk about an assessment on chapter 1 next week. Okay. So I'm going to